Hello and welcome to the video on some parent graphs that we're going over this week. The two parent graphs that we are covering in this video are sine and cosine. We do have one more trig function that we'll be going over in the next video, but that won't be till next week for tangent. But for now, it's just sine and cosine. So first off, starting off with the parent functions. So the parent functions, we got to do a little bit of cleanup work before we start actually graphing these things. Mainly because if you remember from a previous video, I told you that sine and cosine can only be done to angles. So it has to say something like sine of 30 degrees or cosine of 50 degrees, things like that. So cosine and sine can only be done to angles. Now, the thing is that we're going to be graphing. And normally when we graph, we're plugging in x values and we come up with kind of like a straight line. Now, technically, this x-axis can be whatever we want, but most of the time we're going to use radians. So the reason why is because radians kind of works out nice and neatly as far as turning something that's an angle, which is a curve, like an angle of the opening of this angle, it could be thought of kind of like a curve, to a straight line. Okay, so we got to figure out how to connect the angles to straight lines, and radians do a really nice job of that. Because if you remember from a previous lesson, we said that what a radian actually is, it's this arc right here, this arc length. But that arc length is 1 radian, but that's also the length of the radius. So it's like the radius got curved and placed on the circle. So that's one reason why a lot of times we count by pies here, because we're actually talking about radians. It's not the only reason, but that's one of them. So with that being said, we do have to recall the unit circle. So hopefully you memorize this thing from a previous lesson that we did. We actually don't need this entire thing though, so don't let that scare you. We only need the easiest pieces of this unit circle. So the easiest pieces that we did with the unit circle were actually just the ones around the outside, okay? These 4 points right here that are just on the axes. Those points are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So those are the main points that we're going to be looking at here. Now, like I said, we want to work with radians most of the time. At least in this class, it's going to be all with the radians. So it helps to kind of count out the radians. So if you remember, we had 0. Now, we don't really care about all these other ones that were in between here for the special right triangles. It's just going to be these 4 main ones. So if you remember, that's 0. All the way around is pi. That's half a circle. Then all the way around is 2 pi. So if you think about this, if this is pi over here, then right here has to be pi over 2. It's half of pi, basically. And then you got your whole pi, which is half a circle. And you're basically counting up by pi over 2. So you got 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and then 4 pi over 2, which is 2 pi. But if you want to, you can just memorize those. But that's one way you can think about that, is just counting up by pi over 2's, a quarter of 2 pi, right? Because it's split into 4 pieces. So with that being said, you also need to remember that cosine accounts for the x, sine accounts for the y. Just to give you a heads up, I will be going over a shorter method of this. I just want to make sure that you understand where all this stuff came from. All right, and with that, we can go ahead and get started with the graphs. All right, so remember, cosine is your x, sine is your y values for all these points. These are your angles that you're actually plugging into sine or cosine, whichever one we're graphing. Yeah, and then let's get started. So y equals sine x. That's the parent graph. So what we normally did whenever we started with a parent graph was we started with a table. That way we could plot some points, figure out a pattern, connect the dots, and then we got our graph. Now with sine and cosine, it usually takes about 5 points for you to start seeing a pattern. So if you look at this, we got those points right here. We got 0, then we go up to pi over 2, then we come over to pi, then we come over to 3 pi over 2. Then we come all the way around to 2 pi. And those are actually the 5, 1, 2, 3, 4, 5, because that's when we get back to where we started from. And if you remember periodic functions, it's kind of like when you come all the way around and you start repeating the pattern. In a circle, that's kind of clear. You just go all the way around the circle, and then you would just keep repeating that circle over and over again. So you go from 0 up to 2 pi and just count off those pieces. All right, so the next thing is we got our input. Now we got to get our output. This is the input-output table. We got our x's, we got to figure out our y's. So starting off with 0, sine of 0. And remember, sine is the y value. So if sine of 0 is the y value of this point, which is 0. So sine of 0 is 0. Next one, pi over 2. So we're going to go up to pi over 2. So sine of pi over 2, okay, is going to be the y value again, which is 1. So sine of pi over 2 is 1. So input is pi over 2, output is a 1. Moving on to the next part of our circle. And see, this is why it's nice and neat. You can just put these right in. Pi sine of pi is going to be, our y value is a 0. Now, even though we did 0, 1, and we got back to 0 again, that is not a complete cycle. Okay, we didn't get all the way through it because you'll notice these next ones are going to show you why. So this next one, 3 pi over 2. If this was a cycle, 0, 1, you can see 0, 1, 0, 1, 0, 1. You'd see that pattern the whole time. But when we move to 3 pi over 2, our y value of 3 pi over 2 is a negative 1. It's not a positive 1, it's a negative 1. So that's not really the pattern. Okay, you don't start hitting the pattern until you hit the last angle, which is 2 pi. 2 pi radians. We're not going to write out radians though. We were just assuming we're doing radians. And the y value of that is back to the same point that we started at, which is 0. And then if we keep going, if we add another pi over 2 and another pi over 2, you basically just keep going around in this circle over and over and over again. It's a periodic function basically, but this one loops in on itself. Okay. So y equals sine x, that's our table. Now we have a whole bunch of points. So let's go ahead and plot these points. All right, so here we go. Now, like I said, radians is a good way to measure out a linear distance because it's the same thing as a radius. So when we start counting off our x-axis on our coordinate plane, you're going to start from 0, then go to pi over 2, pi, 3 pi over 2, and then 2 pi. These are all the same distance apart from each other because if you look at this, that length is the same thing as this length, is the same thing as that length, is the same thing as that length. So basically, and I skipped the line just to give you a little bit more room to work here. But you start at 0 on your x because your x values are, your x values are all of these, okay? These are all your x values, so that's why we're starting at 0. Then we're going to pi over 2, and then pi, 3 pi over 2, 2 pi. Same thing as over here, 0, pi over 2, pi, 3 pi over 2, 2 pi, all right? So first off, plot that point 0, 0, and there's 0, 0. So right from here, it's just plotting points. So pi over 2, 1 is up there. Pi 0 is right there. 3 pi over 2, negative 1 is right there. And 2 pi 0 is right there. Okay. Now we're just going to connect it with a smooth curve. Keep in mind, y equals sine x. We could have kept going around the circle over and over again. So once you connect this, just make sure that you put some arrows at the end because it does keep on going forever. But basically, this is your graph, okay? Now, the previous lesson, we went over cycles and maximum, minimum, all that stuff. So looking at this, we know it's periodic because I know that I'm just going to end up repeating my values over and over again because it's a circle. You just go around in a circle. But the one cycle that we just did was starting at 0 and then going all the way up to 2 pi. So that's this green drawing that I put in there, okay? So that accounts for one cycle. Now, like I said, this arrow means it keeps going on forever. Let's go ahead and figure out all these pieces of it. We did this in the last lesson, but now that we can see it with the sine function, let's go ahead and figure these out. So the period is how long does it take for one cycle to finish? So starting at 0, if I follow along this green thing, coming all the way across, it takes 2 pi to finish, okay? So my period is 2 pi. Maximum is basically how high does our graph get to and not ever go above. That's going to be 1. Maximum's 1. Minimum's just on the other side, how low can you go? So that would be the minimum. It's negative 1. Midline is basically the line that's right in between your maximum and minimum. So if my maximum's 1 and my minimum's negative 1, the line that's really on the center of that, which is 0, that is your midline. And that's an equation, y equals 0. Amplitude, you're just basically counting how far up your maximum is from your midline. So 1, it's just 1 unit. It looks like 2 because we had this other extra mark here, but that's 1. So it just goes up to 1. Also goes down to -1. That's still a distance of 1. And there is a new term here called the interval. So I took off all this other stuff so we can kind of focus in on this. The interval is pretty easy. Basically, what the interval is, you're going to look at the points that you plotted. What x values did we plot here? So we plotted at 0, going up to pi over 2, and then to this one, and then to this one, to this one. So basically, how far apart are these points? These points are pi over 2, from 0 to pi over 2. That's where your first point to your second point was pi over 2 away from each other. Pi over 2 plus another pi over 2 is 2 pi over 2, which is what pi is, plus another pi over 2 is 3 pi over 2, plus another pi over 2 is 4 pi over 2, which is 2 pi. Okay? Basically, the easiest way to figure out your interval, just starting from 0, where does your next point end up? Pi over 2. That's what we're counting by, okay? And here's just a kind of animation to kind of show how we count it up. So that's 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. If you think about simplifying each one of these, that's just pi over 2. 2 pi over 2 is just pi. 3 pi over 2 is 3 pi over 2. 4 pi over 2 is just 2 pi. You're just simplifying. So basically, interval means what interval are you counting by? I'm counting by pi over 2's. Okay? So that's it. Okay? Let's go ahead and take a look at cosine. Cosine, same kind of thing. I'm going to go a little bit faster through this because it's the same process. We got 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's just the angles all the way around. We're going to plug those in. But now instead of looking at the y value, cosine is your x value. So we're going to look at our x values. So cosine of 0 is 1. Cosine of pi over 2 is going to be my x value, which is 0. Okay, next one up is pi. Cosine of pi is going to be the x value there, which is -1. Then we go to the next one, 3 pi over 2, which is my x value, which is 0. And then 2 pi, cosine of 2 pi, which is my x value, which is back at 1 again. We went around in a full circle. That's how I know this is a cycle. Single cycle means you went around this circle one time, and then you're basically just repeating yourself over and over and over again. All right, so let's graph this guy. Again, I am just marking these off by pi over 2's, right? Because that's the intervals that each one of these points happen in. Pi over 2, pi, 3 pi over 2, 2 pi. Plot these points. I'm going to go a little bit faster here. You should know how to plot points. And that's it, okay? Those are my points. I have enough points now that I can start to see a pattern. So looks like I'm going to start at 0. I'm going to go down, then come back up. And then that pattern just repeats over and over and over again. Down and up, down and up, down and up, okay? This graph down here is basically just a longer version of this. If you look at this, this stops at 2 pi. That's right here. This is basically if it just kept going. So one cycle starts at 0, ends at 2 pi. All right. And the parent functions of sine and cosine, your periods are always going to be from 0 up to 2 pi. You'll finish a cycle, full cycle by that time. All right. And then just to kind of show you what this looks like on the longer graph. So that green part right there, that is one cycle. And then if I wanted to do another one, I would just place another one right next to it. That would be 2 cycles. And that would be 3 cycles. Looks like kind of came off because it has to go up to 12 pi actually to complete 3 cycles. All right. And notice each cycle was 2 pi long. So one cycle took 2 pi. So it makes sense that in order to do 2 cycles, which is double that, you double 2 pi, you end up at 4 pi. And then, that was 11 pi over 2. So double that, or add another 2 pi onto that, okay? And you'll be at 6 pi, which is 12 pi over 2, all right? All right, and then just counting up, this is just showing an easy way to count up. 0 pi over 2, 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, which is 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2, doesn't simplify, 6 pi over 2 is 3 pi, and you kind of get the pattern from there. 7 pi over 2, and those are the rest, 8, 9, 10, 11, and then there's a little 12 on the end. But just simplifying the ones that you can, that's how you get all these markings here. All right, and last thing, 2 pi, again, is your period, and that will be your period, unless we have some type of shifting or transformations going on, which we will, hint, hint. Maximum, minimum, just like before, top and bottom. Midline is the middle between those two. Amplitude is from the midline up to your maximum. This one is 1 as well. There's this extra little line here, but that's like half. So it goes half and then 1. And interval still is just pi over 2. All right. And that's your parent graphs. So your parent graphs are going to stay that way. And that's it. So we're just going to practice the parent graphs for now. For your homework, you're going to have to mark these things off. I'm going to do one more example, so feel free to stick around for this example if you want to see how to fill it in from scratch. So if your problem says, for this example, if your problem says graph 2 cycles of y equals sine x. So what I'm going to start with is I'm going to have my handy dandy unit circle. That way I can keep referencing it until, well, once you get it memorized, you don't even got to reference it. You'll get used to this, right? Now I know that I'm counting by pi over 2s. So I got to fill in 2 cycles. So I know 1 full cycle is 2 pi. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. 4 divided by 2 is 2, so that's 2 pi. So that's 1 full cycle right there. So I would mark off 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, and then 2 pi. Now, I need 2 cycles, though, so I actually need some more. So I'm just going to keep counting. 1, 2, 3, 4, 5, 6, 7, 8. 8 pi over 2, because that's 4 pi. 2 pi is 1 time around the circle. 4 pi is 2 times around the circle. I wanted 2 cycles, so I got to go around the circle 2 times, right? Now I'm just going to simplify the fractions that can simplify. So 2 over 2, 4 over 2, 6 over 2, 8 over 2, 1 half. I mean, technically you don't need that 1 there. And it should look something like this, okay? Pi over 2 pi, 3 pi over 2, 2 pi, and then more, and then 4 pi, right? And that's just going around the circle a whole bunch of times. Now, we only got to do 1 cycle, though, or account for 1 cycle. So you can make a table to help you organize your thoughts. And like I did before, you just got to look at, this is sine, so we're looking at the y values. So 0, 1, 0, negative 1. 0, 1, 0, negative 1, and then back to 0 again. So you just look at the y values and go around. 0, 1, negative, sorry, 0, 1, 0, negative 1, 0. 0, 1, 0, negative 1, 0, right? And then that's your pattern. You'll keep doing 0, 1, 0, negative 1, 0 over and over and over again. So there's your points, right? So plotting these points, you get those. You're going to draw your curve. That's 1 cycle. It says graph 2 cycles. Now, you don't have to make another table. Just do this again for each one of these intervals, because I already know these are my intervals, because that's what I counted by, was pi over 2. So it goes 0, 1, 0, negative 1, 0. So same pattern. So 0, that's my starting point, is where that one ended. 1, 0, negative 1, 0. And you can see it's just another cycle. And then you just draw another one. So that is 2 cycles of sine x. That's what your homework's going to ask you to do, so just make sure that you're able to fill it out like that. Have any questions, feel free to ask. Email, loop mail, office hours, all that good stuff. All right, take care. Bye-bye.